Welcome back to Precalculus. We're talking arithmetic sequences and series today, and let me show you an example of one. Oops, didn't mean to do that. Okay. -3, 1, 5, 9, 13, 17. This would go on and on, but I think you probably see the pattern. It's increasing by 4, right? So +4, +4, +4, and on. So we call this, it's arithmetic because it has a common difference. And we use the lowercase d to show that. So d is 4. Excuse me. D is 4. And so we could actually write this as a sub n equals 4n minus 7. Didn't really tell you much how I did that. Let's talk about where that comes from. So the 4 is the common difference, right? This is kind of like the slope in algebra. Or also, we often call that the rate of change. The -7 is like the y-intercept, or sometimes we call that the initial value. So where this comes from is you need to find your d, your initial value. You need to find your initial value. You might think, wait a second, the initial value, -7, where'd that come from? Well, if you were to back this up and go back 1, it would be -7, right? If you were to go back 4. So if you think of this as the first term, right, where n was 1, this is the second term, the third term, the fourth term. This is the 0 term, where n is 0, right? If you plug in 0 in here, you get -7. It's kind of like the y-intercept is when x is 0. So this is from the book talks about this. Here is their formula that they introduce here. And so as long as you have the 0 term and you know the common difference, you can write the equation for an arithmetic sequence. I do things slightly different because I think about this case. What if you're given, someone says, okay, I got this sequence, arithmetic sequence. The 12th term is 29. The common difference is 3. Write an equation that models that sequence. So if you're using this pink one up here, you'd need to know the 0th term, which would take a little bit of time. So I have a better idea, I think, and it does this. It says, okay, you want to find the nth term of a sequence. Any term will do. I'm going to say the m term will be fine. You just need to add to that term a certain number of common differences. How many differences apart? Well, it tells you have to take the difference of their indices, the index value, the subscript. So for example, anyway, that's what I'm going to use. For example, if you want to get to A11 from A4, to make them equal, you need to add on 7 D's. 7 I got because 11 minus 4. So I call this the arithmetic Navigator Formula. So it helps you navigate. You can find any term in a sequence. You can find equations. So now I'm going to do with this. I can say, okay, I really want the nth term. Let me kind of back that up here a second. So what they ask you to find a sub n. You could say, okay, you want a sub n? You got a sub 12? You can do that. You need to add on a certain number of d's. How many? N minus 12. So if this a12 is 29 and d is 3, so I can distribute and get 3n minus 36. And finally, I get the answer, which is, very interestingly, almost the same as the previous one. A sub n is 3n minus 7. And if you put in 12 for n, you get 29. Or any other number, you can get that term number. And we can use this similarly on a problem like this. If you're told that the sixth term of a sequence, let me make this a little smaller. Sixth term of a sequence is 30, and the 15th is 52.5. Find the nth term. Okay. So what we could do is use our Navigator formula. It says I got the 15th, I got the 6th. I better use those, right? Well, to get from the 6th to the 15th, you need to add on a certain number of d's. How many? Yeah, 9, which we got by doing 15 minus 6. So you plug in what you know, 52.5, 30. This becomes 9, and you can solve for the common difference, because we need the common difference if we're going to write the equation. So you subtract, get 22.5, and then divide and get a very nice 2.5. That's not our final answer, but it's going to be useful. It's going to go up this way. So now I want the nth term. I can use either one of these. I'm just going to use the sixth one. So how do I get from the 6th to the nth term? I need to add on n minus 6 d's. So 30 plus n minus 6 times 2.5 with my answer. So we simplify this. And we get a sub n equals 2.5 n plus 15. Okay, so you can plug in 6 for n, you'll get 30. You can plug in 15, you'll get 52.5. So it works really nice. So let's go back to the classic problem that we talked about, I believe in 9.1. That classic problem was, what is the sum of 1 plus 2 plus 3 plus 4 plus 5 all the way up to, I think we went to 100. I'm going to go to 99. You'll see why. Let's see, 95, 96, 97, 98, 99. Now, I believe I might have left this as a cliffhanger in the last video to see if you could figure it out. Did you figure it out? I kind of gave you a little bit of clue the way I wrote it here too. If you wanted to find this sum, and I don't know if you've done this before, but when I'm playing a game like, I don't remember if I said this in the previous video or not, but when I'm playing a game like Uno, and these are my cards, let's say. I have a 3, a 5, an 8, a 7, a 2, I don't know, something like that. So how do you add these? Well, what I do is I find the ones that go together well. That's 10, that's 10, so it's 25. 2 10s and a 5, right? So that's a nice way to do it. So here, do you see any that go nicely together? Like the 1 and the 99 are 100. The 2 and the 98 are 100. The 3 and the 97 are 100. The 4 and 96. The 5 and 95. There's a bunch of hundreds here. How many 100 pairs are there? Well, let's see. I know I'd have 48 and 52. I'd have 49 and 51. And then I'd have 50. Okay, so if you count all the pairs from 1 to 49, that's 49 pairs. So I have 49 pairs, and they all add to 100. I can call it the pair sum. And then also I have an extra 50. That poor 50 has no one to go with. So these are 49 hundreds plus 50. It appears we should be at 4950, and we're right. How did we do that? Is there a way to generalize what we did? Yes. So we're going to use capital letter S for sums. So the sum of n terms, you need to find the number of pairs. So number of pairs. In this problem, it was 49. You need to find the pair sum. In this problem, it was 100. You might be thinking, wait, what do you do with the extra if you have an odd number? Well, this will be really interesting. How can I get 49 from this? If I did 99 divided by 2, that'd be pretty close. It'd be 49.5. In fact, you're going to do that n over 2. You know what if you did n over 2 on this one? It would be 99 over 2, 49.5. The pair sum is just the first plus the last, or the second plus the second to last, or the third plus the third to last. Easiest way to label that is the first plus the last. Write that again. There we go. So that is our formula for sum of an arithmetic sequence. So in this previous problem, our pair sum, 1 plus 99. Again, you might be worried about this 0.5, but check this out. It's 49. It correctly gets it that half of the pair sum is always going to be your extra number, because that extra number is right in the middle. It's always going to be half the pair sum. So if you have a decimal pair, when you divide by 2, it's going to work itself out because it's going to be multiplied by the pair sum. It will work. So